Hey guys, I'm back after a few months break. I noticed the tutorial wasn't really complete, and now I've had more time. I want to kind of finish it. So one of the biggest things that was missing in it was how to use plastics. Right, one of the biggest advantages of CAD is you can use custom plastic, and right, there's not that big of a point CADing if you're not going to include custom plastic pieces. So this video will cover from some sort of basic plastic, which is basically all you need for VEX, and also a bit more advanced plastic that you might run into in the future. Okay, so first off about plastics, it's actually pretty simple. It's all about just sketches in Fusion or any CAD software you use, and really what you can do with the plastic is highly depending on your I guess the CADing skills, or it's not really how good you are at VEX or whatever. It's more how good you are, how comfortable you are with the software you're using. So to start off, I have already made this intake little thing for high stakes. Obviously, don't use this intake. If you use this, it's gonna bend and everything. But one other thing I want to do is actually I want to triangle brace from here to here on this intake. And then if you want to, for example, reduce weight, right? Using maybe an angle, using a like standoff or something might be pretty heavy, and you want to reduce weight, and it's not that structurally important, then plastic might be an option for you, and I'll show you how to make it. So first, you want to create a sketch. Now notice when you create a sketch in Fusion, you need a plane to create a sketch on, and a plane in this case can just be anything, which this face here also counts as a plane, but let's assume that you don't have a plane that you can create a sketch on. Then you have to create your own plane. I'll show you later in the video how to do that as well. So first, click create sketch. Make sure you don't do this. Don't put it on any of the origins. Put it on the surface that you're trying to make the plastic on. Once you're inside the sketch menu, one of the key buttons that you need to know for this is called project, and keyboard shortcut should be default to P. And I'll see here this window that pops up. I'll just show you where to find it. It is here in create project include project. Okay, so what project does is you see these sketch points on the C channel. Right now, if you create a sketch, you cannot select those points, right? But if you project, let's say this point, and press OK, now you can select this point inside of your sketch. So when you create a plastic piece or CAD for VEX, you don't want to be estimating, like guessing where something is, right? That's just how you end up with bad spacing or something along those lines. That's not what you want to do. This is where you want to project. And I believe in Fusion 360, the default face that you created a sketch on, or the plane here, everything on this face will already be projected for you, so you don't have to project for this. But in other CAD softwares like Inventor, this is not the case. So once I have this, you want to make a hole, because this is where the screw will go. The spacing I like to use is 0.172 inches, but this is, I believe, not the perfect spacing. I think the perfect spacing is slightly smaller than this. And then obviously this hole on the C channel, I believe, is actually 0.182 inches, but it doesn't really matter what you use, just make sure you use big enough so the screw fits. And let's say I have that hole here, I want to maybe put it on this hole, 0.172 inches. And you'll notice there's actually a difference. You see this line is white, which I believe is actually not the default. I believe default in Fusion is black, and this one's blue. So the difference here is the blue one, see, I can drag it around, and the white one I cannot. So what this color, which I believe default is black again, but mine's white, tells you that is that you have enough constraints, I guess, on that sketch where it is fixed, it cannot be moved. And when you design plastic, usually it's best practice that for every single one of your line to be white, or in your case probably black. So the reason actually this one isn't white is I forgot I guess the sketch point is not actually included, so you probably want to project that as well. And see, once I drag that on here, now it becomes white, and that's perfect. So if you go back to the project window, you'll see two things. We've been using this specific entities, so that's for sketch points, face, line, but you can also have another option called bodies. which just selects the entire body. This is a nice thing that Fusion has that I guess Inventor doesn't have, which is pretty cool. But I'm gonna project both of these bodies on to my sketch. I see a lot of points show up. Again, this is actually very like, it could become very laggy on big CAD, which is part of why you might not want to do this if your computer is not good enough. But normally it doesn't really matter. So see, the reason we want to create these purple lines. Oh, by the way, any line that's purple, which I believe is also default color, is purple. Is any line that you project on. So, but basically the reason we want to do this is so we can create a piece of plastic that's kind of like flush with the metal, right? Because you don't really want your plastic to be sticking out like out here. That's not great, because if someone rams you, the plastic can snap. Also, just doesn't look good. So by doing this, you can make sure once you've built it in real life, it becomes flush with the metal. And let's just say I'm gonna put a line across here, line across here. Now this is something that I won't go into, but you see all of these constraints, I won't really explain what they do. It's maybe except for a few minor ones if it comes up, but these, you should know what most of them does. Especially I like to use coincidence, parallel, and perpendicular, as well as tangent. These are really cool. But this is more Fusion related, it's not really VEX related, so that's something that you will just have to find out yourself. Another button that you want to know is sketch dimensions, which is keyboard shortcut D. Again, this is a Fusion thing, but it is super important to use this when you're making plastic, because you can see here I can put a dimension from this line to here, which, as you can see, the line turned white, which is good. I'm just gonna put a 0.25 inches. That's a value that you normally use, but it doesn't really matter. Okay, once that's done, I'm gonna just create a kind of a box shape here. Sure, but you see this doesn't go over this line, so what you can do is just click here, parallel. Now it's on the line. See, everything's white. You cannot move it anymore. So once that bit's done, let's make this a triangle. And see, after I done that, right, this thing is shaded in, whereas before, if we go back, right, there's like nothing here. So what that tells you is that the sketch, I guess you could say, is closed. So you could extrude the bit in here. So if this isn't shaded and you want to make a plastic, then you probably has a hole somewhere in your sketch. Maybe you want to zoom in a lot and realize this point isn't actually touching that point. Something like that could be a problem. But for this case, that's not really a thing. And then I'm just gonna, let's say, create a small triangle in here. Why? Because it looks nice, and also you conserve plastic. And then we're gonna make it parallel. Okay, so you want to make it parallel, parallel. This should be parallel as well, and then make a dimension short here. Maybe it's, that's a little big, so maybe 0.625. Same goes here. 0.625. Actually, those are a little small, so I'll change it in a second. Maybe 375 here. Maybe 0.5 here. 0.5 here. Now these aren't really that important. I just kind of create this little pocket in here because it mainly looks nice. Also, maybe in some bigger plastics, you want to conserve plastic to fit something inside of the plastic limit. Okay, now once everything is done, you're happy with what you have, you finish sketch, and then you press extrude, and then you'll create the plastic piece itself. But when you extrude, make sure you cover every face. This is one thing that's actually really annoying about Fusion, which is when you project a whole object. Maybe I shouldn't have done that. You see every single one of these holes becomes a hole, and that's not really what you want, but not that big of a deal. And then the spacing for every single plastic is 0.0625 inches. And then see here, but one thing you'll notice is black, which is the color of the aluminum underneath, which usually when you CAD and you see this, what it tells you is it's becoming part of the components underneath it, which I mean it's not good. So to change that, here operation join, instead make a new component. Remember, for VEX you basically always want to work with components. So new component, press OK, and then basically you can, as long as you can tell the color is different from the background color, then you know you did it correctly. If it's the same, then you probably accidentally joined them together. And one last thing that you want to do is you want to get rid of these sharp edges, mainly because sharp edges aren't like great in real life, and also they look nicer without them. I like to get rid of them. I guess you don't have to, but it's nice to do it. So to do that, you press F for fillet, yeah, which is this button right here, and you just select the edge. You can move it in, see it smoothens it out. So let's just say I want to select. Actually, I don't know why I can't select. Oh, you have to press this plus button. Oh, never mind. Okay, whatever. See, I've been using a lot of Inventor, so this is like, actually I kind of forgot how this works, but you just create fillet here, let's say 0.25, and then do the same for every other edge, as well as the inner edges. Well, you notice I may have filled it too much. So nice thing about Fusion, you have this timeline on the bottom. You can just come into here, edit feature, and just decrease this, right? But see, now once you've done a sketch, right? And let's say you aren't really happy with it, it's something you want to change. For example, right? You probably want a hole right here, just saying. But then, so how do you change this? Well, luckily in Fusion, all you have to do is just create a sketch. Make sure this time it's on top of the other sketch. I mean the plastic you made. Press project again. Project the hole, which, oh, because I have body selected, so I can't just project a single point. I project a point, press OK, and then create a hole here. Alright, now that is done, if you have a component, notice you can just copy and paste it, and you can just use joint to put it on the other side. Now if you did this with a body, you cannot do this, so that's why you want this to be a component. And obviously you can rename this if you want, but I'm just not going to do it for this sake. Alright, another thing I'll cover here is, you see this has a really how can you say this, metal looking appearance to it, which is obviously not how plastic looks in real life. And this is a minor thing if you want to change it, but here is how you can change this. You can press A for appearance. I'm actually not sure where it is, but if you press Shift S, not Shift S, sorry, Shift, actually I forgot the button, but it should be bind it to A default for appearance, and underneath you see plastic, and then choose whatever plastic you want. Obviously there isn't Delrin, there is I believe polycarb though that you can use, but I mean I don't really know if you want to use a clear plastic, but here you can just drag it in this design and then put it on top of where you want it, and that is basically how you do a basic plastic piece. And next up I'll show you how to do something more complex, where having the cast software is actually extremely helpful, or something that if you're trying to do it, I guess, by hand will be really hard. Okay, continuing on, one of the biggest, I guess, advantages of CADing your plastics is you can make custom gear mounts like this. So in this case, I want to stick this 5.5 watt motor onto the intake and run this gear ratio, but you'll see with VEX metals, sure you could have this spacing, I guess, for this gear mount, but it might be a little inconvenient, and let's say you just want to use a plastic for instead, and I'll show you how to do that. This is not a great example of this because you could get away with using metal in this case, but in some cases where you want to just design a full custom plastic thing, it is more useful. So again, to begin, you create a sketch, and then let's just put it on this face. And then what you want to do is you want to project the center point of the gear, and then basically this gear, which will be the fixed gear, and you're trying to find out where to put this gear. Okay, and then you create a line. Don't put any constraints on it right now. I'll show you what to do in a second. But basically what you do is you find the VEX spacing between this gear and this gear, which I don't have it off of the top of my head, so this is what I usually do. I just copy this to like a C channel in the background. I'll put it like here, like mostly lined up. I'll copy the other gear, right, and then I'll stick it on, and you'll see this is about right. You find the distance between this and this. I'm gonna copy this. Now, here usually you want this precision to be max, because this obviously doesn't always line up, especially for, let's say, 48 tooth gears to 36 tooth. It doesn't always line up, but in this case it's just 2 inches. I'm not gonna even bother about it. It's just but you have to just remember the number you get, and then you can delete the 2 gears. Alright, now back to the sketch, which again you can access on the timeline. Go edit sketch, and what you do is you want to constrain this. Actually, you can't do it that way. You have to go from the point to the point. Yeah, like this. Make it 2 inches. Alright, now it's basically anywhere along here the 2 gears will mesh perfectly. Since I kind of line up where I want this gear to go, I'm just going to roughly put it there, which looks about right. And again, you want to probably constrain this, so you can just create a line. I like to do it this way and create an angle constraint. One thing you notice what I did with this line is I made a dotted line. What that's called is a construction line. You can just do it here with this button. What a construction line does is a line basically used for construction. It doesn't actually show up in the actual final thing you extrude, so it could be useful for some things. And then again, you put a dimension or like constraint here, make that, let's just say 60 degrees, sounds about right. Once you have that point there, make a hole that the other gear will go in. Let's just say I'm gonna hide this gear for now because it's a little distracting as well as the motor. Okay, once you have a hole, right, now you want to mount the motor. The easiest way to do this is just make a line like this. Okay, make a construction line, and for each of the VEX holes the spacing is 0.5 inches, so you just make 2 holes like this. Make this 0.5 inches across, here and here to be 0.5 inches. Very nice. And then after that is done, you can kind of just create this plastic. I'm not gonna spend too much time on this. It doesn't really need to be perfect. When you do it, you might want to spend more time than what I'm doing here, but this is kind of how I like to do it. I like to just like maybe something like this. You'll notice that I'm not really caring about what it looks like right now, because it doesn't really matter. This is something that you can fix later. You probably just want to get out the rough shape of what you want the plastic to look like, so you can visualize what's going on, right? And now after you're done all that, you want to probably constrain this. So let's say I do, actually I don't like, see, this is where drawing it out maybe like this helps. Let's say I don't really like the way that looks. I want it to maybe look more like this, so I can just drag it around. No, now I just have to constrain everything. Let's just delete this and then put this point here. Sure, that's good enough. And this is where you use something like the tangent constraint, because you actually do want these to be tangent. And then this here. Oh yeah, one more thing is these lines sometimes doesn't mean it's fully constrained. Like, cause look here, even though it's white, I can still drag this one around. Let's say I want this maybe 0.5 inches. Okay, this height is already determined. Let's say I want this maybe at an angle of 130 degrees. Sounds right, about right. And let's project this point on. Actually, sure, yeah, it doesn't matter. I'll project that point on. Point 1.2, make a hole there, and then oh yeah, one thing to remember, don't forget, is make a hole down here, which you normally wouldn't have, because even though you projected this point, you didn't make a hole for it, right? And then yeah, that looks about right. And if you just extrude this, which again, this is kind of what's annoying about Fusion. On Inventor, you don't have to deal with selecting every single one of these like tiny faces, but unfortunately for Fusion, you do have to deal with it. Right. Again, 0.0625 inches. Oh, you'll notice I missed that. I can just click that, make a new component. Okay, now I'll just make all the edges round. Again, this is not ideal piece of plastic. You probably don't want to run a shape like this. I just make the quick example. This thing will probably snap pretty quickly, so that is not something I would do. And then again, you want to remember, you want to constraint your plastic. So let's just put it on to here like this. Sure. And then now once we put the gears back on, and then we attach this gear, we attach you to here, you'll notice that the two gears are meshed very nicely with each other, almost perfectly. So that's very nice. This is something that you would do. Maybe in this case you could get away with a metal piece, but there are definitely some use cases. I think this is one of the biggest things that I found out how to do that is really nice to know. And then other than that, it's more just minor, smaller pieces of plastic that you'll like, if you are good enough at CADing with Fusion, that you can make any pieces of plastic. This is just one thing that I've learned throughout the years, and this is like something that I think I want to show you, so you guys don't have to spend as much time as I did to figure this stuff out. Okay, one last thing about plastics in real life is that you can bend them. You can either heat bend them or just cold bend, like manually bend them, like for example polycarb. So now I'll show you how to actually do that inside of Fusion 360. So what's kind of nice, if you kind of get comfortable enough with this, you can incorporate these like bending plastics into your CAD design. For example, you're making an integer ramp, you can do a bend, and then you can find the attachment, for example, like something like that. But this is just a nice skill to know in general. So in this case, let's say I want to create a small ramp at the front of my intake that goes like across and down to maybe wedge rings, and this is how you would do it. So first off, again, you want to start by creating a sketch, and then again projecting. This time I'm not gonna project the entire object because it was a little bit annoying. Realistically, all you need to do actually just project the edges, the points where you want your holes to be, and then the edges on the other side, which you actually don't even need to do this bit, but you do it anyways. And then I'm just gonna create a rectangle, something like this. Sure, that works. And then we're again gonna constrain it, so that will be 0. Why does 0 not work? Okay, whatever. On Inventor you can type in 0, I guess, not on Fusion. I think, yeah, the coincidence, yeah, that constraint, we'll put it there. And then let's say I want this to be 0.25 again. Now obviously this is not something exactly you would build. Actually, I'll make this slightly longer, like 0.75. No, I wouldn't exactly build this because this plastic is probably gonna snap really quickly, but I'm just doing this as an example. So when you CAD it, and if you want to bend it, you want to CAD the like unbent version basically. So let's say I want to make this 2.5 inches. That's not gonna curve down a lot, but you can edit this later if you don't know what value you want this to be. So basically this is just a square, and then let me put the holes in. Okay, now you can finish sketch, extrude it. Again, remember you have all these random faces that you do have to extrude. 0.0625, and again, new components. You see I missed something right here. I'll just add a feature, put it back on. Alright, so you want to, let's round all the edges. So press F again. And then this one doesn't really matter. I'm just gonna put all four corners together. Now one thing that's a little bit annoying is if you make a mistake, you actually select the wrong edge, you kind of have to restart like completely, but shouldn't be that big of a deal here. And now once you're done this, you get to the point of actually bending it. So the first thing you want to do is convert this actually to a sheet metal. So I believe, let's see, where do you do this in I actually don't remember where to do this in Fusion. Yes, convert to sheet metal here. I guess under the sheet metal section, convert this to sheet metal. Sheet metal rule, you could put this well, I guess whatever you want. Usually it doesn't really actually matter that much, but just make sure the thickness matches up to the thickness you have for this. Okay, once you're done that, you want to create a sketch on top of this, and you want to put a line across where you will be actually bending this. So let's say I will be bending this maybe 0.5 inches from where the hole is. And then, okay, once you're done that, and this is a sheet metal, what you can simply do is bend. Yes, it's something called bend. Select the side, and then, oh shoot, sorry, select the stationary side, so it should be that side actually, and this would be the side that bends. Okay, once you're done that, you notice this pops up. You can just drag this, oh shoot, do not drag it like that. Drag it around. Let's say we want this to be negative, let's say 60 degrees. Again, these are stuff that you can just change later. Once that's done, one thing that's a little annoying is this, I believe. Yeah, you can just hide that. And then after all of that, you have a vent, and let's again change the appearance so it actually looks like a plastic piece. Okay, so you have this, but one thing about this is it's kind of annoying when you export this whatever, right, to have a cut. So you can do create, I believe, yes, create flat pattern, stationary face again, this, and then yep, you'll just have a flat pattern of the thing you bent. Yeah, I believe just press this. Okay, and that basically concludes everything that you need to know about plastics for VEX. Obviously, this is a basic to intermediate introduction to plastics. There's a lot more stuff that you can do, but it's not really VEX skills or stuff like that that's the limiting factor here. It's the CADing skills. I think creating custom plastic is one of the only really big bits of CADing that you actually have to do for VEX, and it is really fun if once you learn how to do it and you figure stuff out. Obviously, you can do more stuff than what I've shown you. It completely depends on how good you are at CADing something, but what I've shown you should cover about 80 to 90% of the applications that you actually end up using plastic for. And again, if there's something that you find out that you need the plastic to do this, but then it's not covering this tutorial, you can always try to contact me or just search online, right? You don't have to actually use a how to make a plastic sheet tutorial, you can just basically follow the tutorial on how to create a certain model and use the skills you learned that to transfer that to a plastic sheet in Fusion 360. All that being said, thank you for watching, and good luck in designing your robot.